Technology innovation and entrepreneurship aims to enable innovation in Egypt's ICT sector. VLSI technology is one of the most important fields in ICT sectors. As an attempt for deepening the knowledge of the industry and academia in this field, a grant from MCIT cooperating with Tiec and ITIDA has been given to a group of well-chosen people from different areas in the field, from industry and academia, to travel to one of the research labs clean room in Grenoble, France, to walk them through the MOSFET fabrication process using the hands-on methodology. This video aims to transfer the knowledge and experience gained by the people, exposing the different fabrication steps they went through in their journey, with a very brief description starting with the bare wafer until the testing step. Step number 1. Making the field oxide. The goal of this step is to accomplish the field oxide, which separates the transistors from each other. Photolithography. This process is always done whenever some pattern is to be transferred on the wafer. The steps of the process are: Step number 1. Covering the wafer with the photoresist using what is called the spinner. Number 2. Soft baking for photoresist solidification. Number 3. Transferring the mask pattern onto the wafer using the ultraviolet light. Number 4. Putting the wafer into the development solution. Number 5. Hard baking for pattern transferred solidification. Etching. Etching is done to remove the undesired pattern, leaving just the desired one, which is the field oxide. Dry etching is used here using buffered oxide etching diluted with deionized water. Photoresist etching. The pre-developed photoresist is to be etched using a solution of photoresist remover. Step number 2. Polysilicon gate. Photolithography. Polysilicon gate mask is transferred on the wafer and developed using photoresist. Polysilicon etching. Dry etching. The undesired polysilicon is etched except for the desired gate polysilicon. A machine is used here for etching, and the conditions under which etching is done are as follows. Photoresist etching. Removing the pre-developed photoresist. Step number 3. The source and drain doping. Defining the transistor's source and drain active regions. Doping. Ion implantation. Ion implanter is the machine used to implant the dopants into the source drain areas. Thermal annealing. Activating the atoms to react chemically and give the active doped regions is done through the thermal annealing. Heat is not only required for the reaction to happen, but also for reconstructing the damages occurred to the silicon surface due to the ion implantation process. Wafers are put into a furnace to be heated together and left for a long time to be accomplished. Step number 4. Protective oxide deposition. Oxide layer on which metal one will be built upon. Protective oxide deposition. The same machine used for etching is also used in depositing a protective oxide layer cover the whole wafer. Photolithography. Here the photoresist is used to define the places of the contacts we will use on the wafer. Contact mask is to be used. Step number 5. Aluminum contacts. Contacts to the transistor's terminals are to be done here. Sputtering. In this step, the aluminum is to be sputtered on the whole wafer to cover the opened contact places and the protective oxide. A machine is used here for sputtering the aluminum under the following conditions. Photolithography. Now we want to draw the places of the contacts on the wafer, just to leave the contact's aluminum to separate between the contacts. Etching. Here the wet etching is used for etching the aluminum under the following conditions. Step number 6. Testing. MOSFET characterization. A special probing station is used here to test the transistors on the wafer, at which the wafer is fixed, and we have about 4 probes to fix on the wafer for testing it. We can apply voltages on the different probes, sweep voltages, etc. and also get the output plots and get them printed to calculate the values of different devices parameters like V-threshold, mobility, and etc. Step number 7. Modeling. Modeling could be done using a computer-aided design software. We have two software that we have used, which are Athena and Atlas. Athena is a process simulator in which the whole fabrication process could be tried on with the same conditions we mentioned earlier to fabricate what we have just fabricated in real life. Atlas as a device simulator, and is used the same like the probe station at which the transistor is to be modeled and tested for getting the values of the fabricated device parameters.